First question here. We have the 2 points. P is 1, 2, and Q is 4, 8. And we're asked to get the slope, equation of the line connecting the points, and the distance between the points. Again, these are all in your log tables. If you're getting the slope, equation of a line, distance formula, you should know the formulas, but they're in your log tables. So always, always, always go back to your log tables if you're unsure. So, first one, we want the slope. So, what's the formula for the slope? Well, we can use either slope is rise over run, or you can use the formula y2 minus y1 over x2 minus x1, like that. So I'm going to label P as x1 and y1. I'm going to label Q as x2 and y2. It doesn't matter which one you label which, but once you label them, you have to keep consistent with them. So y2 minus y1, that's going to be 8 minus 2. And then x2 minus x1 is going to be 4 minus 1. So that's going to be 6 over 3, which is equal to 2. So that's the slope of the line connecting the points P and Q. So like, imagine Q is like here, P is here, P here, Q here. The slope of this line is 2. We just figured out. Now we want the equation of the line. What do you need for the equation of the line? Well, it's y minus y1 is equal to m times x minus x1. So we need a point and we need the slope. We just got the slope, so we can just plug him in over here for m. And what else do we need? A point. We can use either P or Q. I'm just going to use P. So P is 1, 2, like this, and M is equal to 2. So we have y minus y1, y1 is going to be 2, is equal to 2 times x minus x1, which is 1. Multiply that out, we get y minus 2 is equal to 2x minus 2. Bring everything to one side, we get y minus 2x is equal to 0, or y is equal to 2x. Whichever way you want to write it, they're both the same thing. You're going to get the marks either way. Then finally, what is the distance between P and Q? One more time, in your log tables, the distance formula is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared, like that. So x2 minus x1 is going to be 4 minus 1. So it's going to be square root of 4 minus 1 all squared plus y2 minus y1, that's going to be 8 minus 2. 8 minus 2, like that. So that's going to be square root of 4 minus 1 is going to be 3, and 3 squared is 9. And then 8 minus 2 is going to be 6. Sorry, that should be squared. 8 minus 2 is going to be 6. 6 squared is equal to 36. So that's going to be the square root of 45. You can get that as a decimal or simplified, but basically that is the final answer. That is the distance between the points. So those 3 questions, all you had to do there was look at your log tables, label the points, and just fill into the formula. Easy peasy. Now, next question, find the point of intersection between these 2 lines. Now, there are 2 ways you could do this. You can either take this equation, because it's y is equal to 2x plus 1. You could either take that y and fill it in here, or you could do the way in the notes, which is like a simultaneous equation. You do that because, say here, this equation here is blue, and this guy here is green. What this is going to look like is something like this. You're going to have the blue line going up like that, and you're going to have the green line here going something like that. We want that point of intersection. So you want where the equations are equal. So if we get both of them in terms of y, then we can let them equal each other. So what I'm going to do is I'm just going to fill this y value into this equation here, because I think that's an easier way than doing the simultaneous equation with it. But you can use whichever way you like. So I'm going to have 3 times 2x plus 1 plus 4x minus 8 is equal to 0. Then multiply this bracket out. 3 times 2x is going to be 6x. And then 3 times 1 is just going to be plus 3. Plus 4x minus 8 is equal to 0. Yeah. Then add the x terms together. 6x and 4x is going to give us 10x. And then 8 minus 8 plus 3 is going to leave us with minus 5 is equal to 0. So then x is going to be, bring over the 5 and divide by 10. So x is just going to be a half. But we need the point of intersection. So we need the y value too. And we have that y is equal to 2x plus 1. That means y is equal to 2 times, we have x as a half, plus 1. 2 times a half is just going to be 1 plus 1. So y is equal to 2. That means our point of intersection is going to be 1/2, 2. Like that. Done. Now, we're on the circles. We want the radius and center of each of the following equations. So the first guy is easy. When you see an equation that looks like this, we know it's a circle centered at the origin. So we'll say here, the first guy, the center is equal to 0, 0. Because whenever it looks like that, it's always centered at 0, 0. And then that means the radius is going to be the square root of this guy on the right, square root of 144, which is equal to 12. Then, second guy, a bit trickier, but kind of similar. All we have to do is look at these numbers here for the center. So, in this case, we're going to be taking the opposite sign of what's in the brackets. So we have x minus 2 all squared. So the x coordinate is going to be 2. And then we have 8y plus 8 squared. So the center there is going to be minus 8. And then the radius is just going to be the square root of the guy on the right, which is 100. And the square root of 100 is just 10. So that's that one done. Easy enough. All you have to remember here is the center. If it looks like this, you take the opposite sign of what's in the bracket. And that's the center. Then we have a circle with equation x squared plus y squared equals 100. Does the point 6, 8 lie within, on, or outside the circle? So basically, we have a circle like this. And the radius, obviously, if we just look at the equation, the radius is going to be 10. Now, we want to determine if this point is either outside here, if it's on the circle, it's going to look something like that, or if it's inside the circle like that. How are we going to do that? Well, what's the center of this circle? We know it looks like this, so its center is just going to be 0, 0, the origin. Like that. Now, we want to determine if the point is inside, outside, or on the circle. Well, we know the radius is just 10, square root of 100. Whoop. Why is it doing this? Oh my god. Okay, there we go. The radius is just 10. So let's calculate the distance between the center and the point. So the point is 6, 8, like this. What's the distance between those 2 points? Well, it's going to be the square root of x2 here, or x2 and y2 there, and x1 and y1 there. We're going to use the distance formula again. So with x2 minus x1, it's going to be 6 minus 0. Ooh. Oh my god, everything is going wrong. 6 minus 0 all squared plus 8 minus 0 all squared. That's going to be the square root of 6 squared is 36 and 8 squared is 64. It's going to be the square root of 100, which is, oh my god, which is equal to 10. And that is the radius of the circle. So that means that the 0.68 is on the circle. Because the distance between the points is the same as the radius. The distance between the center and the point we're looking at is equal to the radius of the circle itself. So it's on the circle. And then it says, what about the 0.78? Well, we'll do it again. Square root of 7 minus 0 all squared plus 8 minus 0 all squared. Square root of 7 squared is going to be 49 and 8 squared is going to be 64. So that's going to be the square root of 113. You don't have to round it, but if you did, it's 10.6, something like that. So that's greater than the radius. So that means this point is outside because the distance between the center and the point is greater than the radius of the circle. So that guy's outside the circle. Okay, and then the last question here. We have the line y minus 2x minus 4. That should be equals to 0. I'm going to have to fix that. That line intersects the circle at this, the circle of this equation twice. We need to find the coordinates of the intersection. Well, we have y minus 2x minus 4 is equal to 0. That means y is equal to 2x plus 4. Now we're just going to fill that y into this equation. So we have x minus 3 all squared plus y minus 4. That's become 2x plus 4 minus 4 all squared. All we did was fill y in over here. That's equal to 36. Then expand the brackets. We have x squared minus 6x plus 9. You should expand that out using split and repeat or whatever method you use. I just use this method, it's quicker. And then the 4's here are going to cancel and we're going to be left with plus 4x squared is equal to 36. Then bring everything over to one side. So we're going to have 5x squared minus 6x minus 25 is equal to 0. Now, you could try to use factorization. I'm just going to plug this into the minus b formula. So x is equal to minus b plus or minus the square root b squared minus 4ac all over 2a. Now just fill that in. A is 5, b is minus 6, and c is minus 25. So you're going to get x is equal to 3, and if you do the minus, x is equal to negative 9 over 5. And when we do that, we have to get 2 points. So now we have to fill this x value into our y here. Remember, y minus 2x minus 4 is equal to 0 is the equation of the line. So I'll write that here. Y minus 2x minus 4 is equal to 0. So now we just fill x in here to get y. So we're going to get y is equal to, well, if you move everything to the right, it's y is equal to 2x plus 4. So 2x, 2 times 3 is 6, plus 4 is 10. And then if we do it over here as well, y is equal to 2 times negative 9 over 5 minus 4, or plus 4. And that's going to be 2 over 5. So those are the points. The points are going to be 3, 10, and minus 9 over 5, and 2 over 5. Like that. Boom. Done.